This is lesson 1.3. In lesson 1.3, we are going to be using our skills of problem solving and solving equations, and we're going to also use some previously learned skills. So for example 1, it says you take the measurements shown in the diagram. The right triangles created by each object and its shadow are similar. Can the tree fall onto the house? So when we're talking about similar figures, so this is something from previous grade, and similar figures, remember, have side lengths that grow or shrink by the same scale factor. So they grow or shrink by the same amount. And when we're talking about these similar figures, we can use those with proportions to help us figure out if this tree would actually fall onto the house if it falls this direction. So what we're looking for when we're going to set up our original proportions. So first of all, the bottom part of this tree, this shadow portion right here, is 30 feet. And then the same part on this human down here, this shadow piece for that human is 8 feet. So in my proportion, remember proportion is two ratios or two fractions set equal to one another. So what I'm going to do is I'm going to have one fraction for my person, and then I'm going to have one shadow or one fraction for my tree. So here's my tree, and here's my person. All right. So we have the shadow for the tree is 30 feet. So I'm going to put that on the bottom. It truly doesn't matter if we go bottom or top. But this is the way I'm going to suggest doing it for this one. Shadow for the person is 8 feet. And the reason I'm doing it this way is because then the variable is on the top of the fraction. And that's going to make life a lot easier when I'm trying to solve. So then the other thing that I have to look at is, actually I wanted to color coordinate those. So 30 and 8. And the next thing we're going to look at is the height, because we need to know how tall this tree is in order to know whether it's going to be tall enough to fall and hit the house. So my human is 6 feet tall. So my person, 6 feet tall. And then my tree, it doesn't have a label for how tall it is. So we're going to use H for height because we don't know how tall our tree is at the moment. So if we look at this, what I basically did here is I put the height over the shadow for each of the fractions. So my tree has height over shadow. My person has height over shadow. So I'm just going to write it over here so it's a little bit easier to see the steps. I'm going to use our ideas of solving equations to solve for H. So if I have H divided by 30, in order to undo my division, I have to multiply both sides by 30. I'm going to make them both 30 over 1 so they look like fractions. All right, so 30 and 30 will cross cancel. 30 goes into 30 once, 30 goes into 30 once, which means that I have H left on the left-hand side here. I can also cross cancel 8 and 30, so we can reduce them by 2. 8 divided by 2 is 4. 30 divided by 2 is 15. So then we're going to multiply straight across. So 6 times 15 is 90. 4 times 1 is 4. 90 divided by 4 is 22.5. So the height of the tree is 22.5 feet. So what I need to look at now is, okay, what is the space between the tree and the house? So if I look at it, Here's the tree. That's where the base of it is. And here's the house. So the space between the tree and the house is 25 feet. Well, even if that tree falls backwards towards the house, since our tree is only 22.5 feet, it should not hit the house. So 22.5 is less than 25. So the tree cannot hit the house. In theory, let's be real. Sometimes life happens and somehow mistakes happen and it could maybe, but based on the height of it and the location of the tree originally, in theory, it should not hit the house. All right, for example 2, we are going to look at the information in the diagram below. So the diagram shows statistics for a baseball pitcher. Unit rate or used rates to compare the pitcher's performance in 2019 to his performance in 2020. So what they're asking us to do is compare rates. So again, rates are fractions. It's comparing one thing to another. So for example, if we picked, we'll just do compare strikeouts per walk. So when we're writing it this way, strikeouts per walk tells us how our fraction would be set up. So we would have strikeouts on the top and walks on the bottom. So if we're looking at 2019, we have strikeouts are 100. So that's going to be on the top for 2019. Label this 2019. All right, so we've got 100 strikeouts over, because remember, rates are fractions. And then we need to look at our walks. So same year, walks are 29. And if we do the division for this, 100 divided by 29 is approximately, so we're going to round it, 3.45 strikeouts for each walk. So I'm just going to do per walk. So that's for 2019. Now let's look at the same information, but let's do this for 2020 this time. So for 2020, we have 73 strikeouts over 20 walks. And if we do 73 divided by 20, we get approximately 3.65 strikeouts per walk. So when we're looking at these two pieces of information, 2019 compared to 2020, we notice that there are fewer strikeouts per walk in 2019 compared to 2020. So if we're looking at that and we're thinking, obviously we want more strikeouts than walks, then if we're comparing these two, then it would look like this person did better in 2020 than they had done in 2019. We also could make a comparison with runs per inning. It's the runs earned, by the way, per inning. So if we're looking at the earned runs, once again, separate these by 2019. So 2019, we have earned runs for 19. And our innings pitched for this person was 70. So we're going to do our division. 19 divided by 30 gives us approximately 0.27 earned runs per inning. So less than 1 run per inning for 2019. For 2020, we have earned runs 15 compared to our innings, which were 50. So when we figure this out, it's approximately 0.3 earned runs per inning. Now, I'm not sure if everybody is familiar with baseball, but if you're the pitcher and you're earning these runs, then that's not a positive thing. It's something that you want to keep as low as possible. You don't want to get runs earned while you're pitching the game. So if we're looking at the two pieces of information here, we notice that for this, there were fewer in 2019 than 2020, but this time that's a positive thing, whereas before it was more of a negative scenario. And then for example 3, we are going to be using rates to convert from one unit of measurement to another. So this is asking us to convert 4.8 gallons to fluid ounces. So in order to do that, we need to know some information. First of all, we are starting with 4.8 gallons. Really, really, really important to use your labels when you're converting from one unit of measurement to another. So we have 4.8 gallons. What you're going to do is you're going to multiply it by some units of measurement that you know. So for example, if I made this into a fraction, since there's no label on the bottom, we're going to put a 1 on the bottom of this fraction. But I know that there are 16 cups for every 1 gallon. So 16 cups per, remember fraction means per, means division. So 16 cups per 1 gallon. So if I'm looking at this, those of you who cross reduce your fractions, this is going to be very helpful for you, because if we notice, our gallons are diagonal from one another, so they can cross cancel one another. So now I'm left with cups, but I'm not trying to find cups. I'm trying to find fluid ounces. So we're going to go one more fraction. And I know that there are 8 fluid ounces. We're going to abbreviate this using FLOZ. So 8 fluid ounces for every 1 cup. So again, cross cancel. I've got a cup label here and a cup label here. So I'm now left, the only label I have left is my fluid ounces. And that's what they're asking me to find in my original question. So in order to do this, what you're going to do is multiply straight across the top and straight across the bottom. So 4.8 times 16 times 8 gives us 614.4 fluid ounces. Now, what has happened in this example is all of the bottom numbers in my fractions are a 1. So technically, I would start with it being over 1, but we know that that would simplify to just 614.4 fluid ounces. If you have a number that's not 1, you have one more step, and you take the top number divided by the bottom number to get your final answer. So it's kind of like when you simplify your fractions, you have that one final step to do. This one, it just happens that all of my bottoms, all my denominators are 1, so I don't have that last step to do for this example.